Good afternoon, everyone. Welcome to this NITheCS Mini-school monitoring biodiversity using data cubes, techniques and applications for open science by Dr. Sandra MacFadyen and Maarten Trekels. Thank you very much for all the trouble preparing this. We really appreciate your valuable time, and welcome also to all the attendees to this mini-school. So people are here to listen to you. I hand over. Welcome and thank you once again. Much appreciated.
Great. Thanks, Renee. I hope everyone can hear me. As she's already welcomed everyone, this is the third session of monitoring biodiversity with data cubes. Myself, Sandra MacFadyen, and Maarten Trekels will be taking you through these different lessons. And yes, last week's session and today's session is going to be very hands-on. Just to give you a breakdown again, the progress that we're making, we've gone through session 1 where we had an introduction to biodiversity and data cubes in general. Maarten took you through a tutorial last week on building data cubes with GBIF data, and he took you through a hands-on tutorial. And today we're going to be modeling with those data cubes. So I'm going to take you through the process once again on how to create your own data cube using not only GBIF data, but data through GitHub or G Drive or anything like that. We will be using Google Colab and Earth Engine. So once again, if you have not set up those accounts, please do so before we carry on. We will be accessing a Google Colab or Jupyter Notebook that we've put on the GitHub site. I will send you the link for that so that you can follow along. And you'll be able to visualize interactive maps in that way, as well as analyze patterns of species diversity related to different environmental variables. Last week, we'll be doing some open science, looking at how do you share and disseminate results. And that will also be a hands-on session with GitHub. But Maarten and I had a quick chat before we started this session, and we're actually going to share with you a Google book, or sorry, a Google Word Drive, so that you can actually type in any problems you've had with the last 2 sessions. And based on that, we might change up the last session a little bit so that we can rehash some of the problems that you've been having and go through things that you might have specifically had problems with. So we'll put the link in the chat. I'll also chat about it at the end of today's session. And in there, we'll also have a brief section where you could give us an idea of what you'd like to see next. So please add your info in there and we can address it hopefully in the next session. Once again, Maarten and I are always available, so you can email us if you have any issues that you'd like to discuss in more detail. All right, as I said, you need to have these accounts set up. The last 2, I think actually, yeah, the last 2 sessions are already up on the NITheCS YouTube site, so you can go and re-watch that if you need to. But please make sure you've got these included. And then today we're going to take you through this practical once again on how do you start with ecological modeling when you have data cubes. So these are the accounts that you have to have, the Colab as well. But there was a problem last week I noticed with the API, being able to connect to Earth Engine through a Google project. There was some issues with that in terms of authenticating it. So I'm going to go through that a little bit slower in the beginning just to make sure that everyone can actually access the different sites and access the API through Earth Engine. And then we'll carry on with the Jupyter Notebook. I have put in here a few screenshots that will lead you through it. So if you want to watch the recording later, you can then actually go through the steps on your own, but I will be doing it live in a few minutes. So here is the link to the notebook that we're going to be working through today. It's on our GitHub repository, our NITheCS GitHub repository. So I think Maarten's going to paste that into the chat box so that you can click on that. And then I'm going to turn off the slides so that I can do it more interactively. Just want to check what I've got here. All right, so that's essentially what it's going to look like if you click on the link that Maarten's pasted into the box. All right, so let me end this slideshow and then I'm going to switch over to a live version. Okay. Okay, so I'm turning off the slideshow and now we'll just take that Google link that you should have had in the chat. Yeah. So if you click on that link, it should come up like that. Does everybody have monitoring biodiversity and data cubes and techniques open on their screen? If not, Maarten will help you out while I'm going through the tutorial. So the first thing we need to do, because this is sitting on GitHub, you can't actually run the code in this environment. So we need to open it up in Google Colab so that you can actually execute the code as we walk through it. So the first thing that you do is click on the button at the top there that says Open in Colab. When you click on it, give it a few seconds and then it should switch you over to the other tab that asks you to use, to authorize GitHub to use it through your Google Colab account, which is linked to your Google account. So it should then be connected. It's going to take you through this, ask you for authorization. So this is my GitHub repository. So I'm just going to authorize it. So you should have had a similar thing that jumps up. It says notebook not found. All right, it says notebook not found, but it is here. So I don't know if any of you had a similar problem, but it does link up here at the end. So you can just say authorize and OK, and then you should end up with this Google Colab short notebook, Jupyter notebook. All right, so now importantly, once this is opened up, this is still connected to GitHub account. So you'll need to save a copy of this on your local or your specific G drive. If you don't do that, some of the interactive sessions where you have to make a map, they won't work. They'll give you an error that says that this is not a trusted notebook, and then you'll have to go through a whole bunch of steps to verify that. So what you can do is just click on File and say save a copy in the drive. When you do that, it's going to tell you that it's copying at the bottom, and then it should open up a brand new screen where it has that exactly the same notebook, but you'll notice it's been renamed now to say that it's a copy of Colab. So that means it's copied it into your drive. So now you shouldn't have any problems with not having a trusted notebook that won't run some of the code. So I've tried to make the notebook as comprehensive as possible so that you can work through it on your own as well. So if you lose us at certain steps, rather than trying to catch up in the middle and then getting lost further on down the line, you can go through these on your own and actually try it yourself. And my email address is up here, so please just email me if you have a problem. So a lot of this is just text. We're not going to read through all of it, but it's there to help you when you go through it on your own. The practical session 3, you'll see also on the side here, you've got the different sections. If you click on each of them, it will it'll allow you to jump to those different sections. So the first step is the setup. Now, Google Colab, the reason it's so nice to use is it's already got a whole lot of the packages and the environment set up for you. You don't have to do anything on your local machine. But having said that, there are a few packages that don't come standard with Google Colab, so you need to actually install those. So these are the ones that I know are not specifically loaded into Colab. You can add to this list if you find that later when we come to this load packages, if you get an error that says that a certain package doesn't exist, you can just pop it in here and then it will install it automatically. Or at the bottom here, you'll have a thing that says quick install. So if you just want to install one, just uncomment one of these lines and replace the package with the name of the one that you want to use. Now, I'm not going to go through the finer details of Python. It's very similar to R, which I think most of you are aware of. These lines here with the hash, those are the comments. Anything else is either defining a function or calling an object, very similar to an R environment. So whenever you see a green section, those are commented out. If you hold down your control key and press the \, you'll see it comments it out and then it will run. Doing it again will comment it out again. All right, so if you run this, it should take a few seconds, depending on your network. So this is running in a sandbox, so it's all running online. So if you have a slow network, a lot of these functions might actually be a bit slower. All right, so it's busy installing Rastio, which is the last one in the list. So it told you there, the reason this is such a long process, whereas this one here is quite short, in doing it this way, it searches in the list of packages that I've put, and if it's already installed, it's not going to try and reinstall it. So that's the benefit of doing it this long way compared to this shorter way. Now, if you go down to load packages, press this little play button to run the code. And it's thinking, you can see that little green arrow moving down as it goes through each of the different packages and tries to import it. I've also tried to put as much detail as possible for the different packages and what they mean. And those who are not familiar with Jupyter Notebook or Colab, a little green tick means that it's done. So you don't have any errors jumping in the output at the bottom, then you know everything is fine. All right, so now this is the step that we had a bit of problems with last week. So we need to authenticate a Google Earth project that you've already got loaded in your Google Cloud account. So if you've already done that and you know the name of the project, if you run this, it should bring up this message that asks you to allow the notebook to access your Google credentials. You say allow. It will then just bring up these screens that asks you to choose the account that you're working with. So I'm not working in that one. I'm working in a different one. I'm working in my NITheCS one, so I'm going to change it. And I can't remember what my password was, so quickly check it. All right, so put your own password in there and your own account. And then you click continue. And it's telling you if you want to authorize it. You continue. All right, so here I wanted this to happen so that I could show you. So this is telling me now that I've got an error. So if you get a little exclamation mark here, that means that that piece of code is not running correctly. And it could be for a number of reasons. One of the issues that you had last week was that your Google project was not initialized to use the Earth Engine API. So if you go into the Google Console page, so in the chat, I'll paste it. All right. So if you click on that, it's going to take you to this Google Cloud Console. All right. And now the first thing you need to make sure, if I click over here, so Google Cloud, it tells me all the projects. I click there, I see I don't have the project that NITheCS that I've put in my project. So if you're like me, you might have multiple Google accounts. And that's the case here. So I've actually logged in with my other Google account over there. So I need to change that. So I must switch it to my NITheCS one. All right, once that happens, now you'll see there's a different list of projects. And this is the one that I want, this NITheCS. And importantly, you need to have the ID of the project, not the project name in that notebook. So make sure you check there for the ID and you copy that. And that's the name you're going to paste into the tutorial for the project that you're accessing. Now, if you're still not getting a connection, it could mean that you have not added the Google Earth API into your project. So if that's the case, you can check that by making sure you're in the right project. And then on the navigation menu over here, if you click on it, it opens up a whole lot of options, one of which is this APIs and services. If you click on it, right. Thinking. All right, you'll see here I've already got the Google Earth Engine added in here. If you haven't, that means you need to enable an API and a service. So you would click on this button and you would search in here for Google Earth Engine. All right, and there it is. You click on it. And then, okay, mine is already added. So it gives me a manage button. On your side, if you haven't already added the Earth Engine API to your system, it'll be add or initialize or something like that. So you want to be able to click it to the point where you get this little green tick. And that should initialize the project so that it will work. Your project will work. All right, so I'm going to close that because I'm done there. I'm going to close that. All right. So here we are. All right, so sorry, let's just go back down here. So now let's authenticate again. So you can run it again. Right. So it gave me a different error, but it's good. Let's see any errors that I get, you might get. So we want to be able to troubleshoot it as we go. All right. So it says E is not defined. I think I actually opened a different. Oh, so this version. I'm sorry, I can't see at the top here because this Zoom system is actually covering the top of my page. So I'm just going to minimize this a little bit so that I can see it. Yeah. So you see, this is the first one that I opened from GitHub. So this isn't the version that I copied to my drive. So if you're running that, it might still work up until the point where we start making interactive maps, and then it's going to ask you to copy it to your local drive. So if you haven't done it yet, it's fine. It shouldn't have given you an error quite yet. But I'm going to leave that one. Okay. So you want to be working on your copy of the Colab notebook. So I'm just going to run this again to double check that everything is working. Okay, so it's going through that step again. Okay, it's already installed. I'm just going to load the libraries again. Okay, it was fine. And then if I authenticate, let's have a look. Okay, so now it worked. If you got any other errors, we will circulate the Google Doc for you to add info in that you can address privately or somewhere else. If you're running in Colab, which you all should be, you can mount the drive. So that means that we can access data that's directly on your Google Drive, and we can also load data that you've already got in your Google Drive. So I'm going to mount that. You might also get, all right, so I've already mounted this. On your side, you might get a message that is very similar to authenticating your Earth Engine project. It's going to ask you to allow it to connect to your Google Drive. It's going to ask you to authorize it. So you just have to click those different screens. It's also in the slideshow if you want to look at it on your own time. All right, so let's go through the steps of loading data. I've tried to be quite comprehensive in this tutorial, and you'll see there are some sections that are commented out or some sections that I may comment out as we're going through this, just to save time, that you could use on your own. One of the very useful ones that I've just added in here, this will only work in Colab. So if you're someone who has downloaded this notebook to your local drive, this won't work because you'll be running it locally on your own Python environment. This will only work in Colab. But if you run this, you'll see it brings up an option to choose a file. So this is the part where we asked you if you had your own data that had coordinates and species names, for example, or anything with a spatial latitude and longitude, you could work on it on your own when we go through these. So if you choose files, this will take you to your local drive. Even though this is running through Google Colab, it will allow you to upload stuff from your local directory. So if you have your own data, I'm going to choose this one, which is on my drive. I'm going to open it. It tells you there, this is the name that of the file it's accessed, and it should give you a little preview of the first few lines to show you what that table data looks like. So I'm running through now the different ways that you can read in data, because I think that's the trickiest part, is being able to access data and being able to use it going forward to create these data cubes. If you have data on your G drive and you know the path of that data, you can do exactly the same thing. But this way you're specifying the specific file. All right, so if you run that, you should get the same table in a way. All right, so if you want to access data through a GitHub account, which I've added on our GitHub account, some sample data, you can run that. All right, and this is now a different data set. But what we want to do is be able to access the data directly from GBIF. So Maarten showed you last week how you use GBIF to query data. So here is an example of butterfly species that I access from GBIF for South Africa. So if I click on that DOI, okay, you'll get this. So this should look familiar from what Maarten presented last week. But this is specifically observations for butterfly between 1998 and 2023 for South Africa. And it tells you that there's 81,825 occurrences in this download. So if you've gone and created a similar thing, and you want to now access your data that you've summarized from GBIF into the notebook, this download button on the right-hand side, if you right-click on it, you can copy the link. So that's going to give you, this link here that you can paste into the URL. So before we can do that, I wrote a function here that's called load URL from zip. So this function will allow you to take anything from any of those zip files that are downloaded from GBIF to paste that URL directly into the function and be able to access it. So this case, we just run it to create the function so that it's now loaded into our memory. So it knows now that this is a new function. So now I can run that function. All right, here's the function. So I can run that function on this URL. That's the one I pasted from GBIF. All right. So I'm just going to run it. And if you have different data that has different names, you can also go and change that. But if you're using GBIF data, all of this is standardized, so you don't need to worry about changing anything. This then filters out only these records. So what this step does is it's saying GBIF has got a lot of different fields, but for the purposes of this tutorial, we're only going to keep these ones. So if you have other ones you want to keep, you can add to that. But this function there is what actually brings the data in. Now what you can do is you can start looking at your area of interest and start doing some analyses. I also wanted to illustrate to you that you could bring in data from GitHub of a different type. So we've already looked at how you bring in CSV files. This is a shape file that I've also loaded onto our GitHub site. And you could also upload files directly. So that's another one of those options where it's going to ask you to choose a file. So if you have one on your local directory, but I've commented all of those out for simplicity's sake to run through this tutorial. But on your own time, you're welcome to uncomment them and try and run the code again. So if we run this, we've essentially brought in the boundary for South Africa, including Lesotho and Swaziland. Then here's another function that I've created for you. So you don't need to fiddle with the function, you just need to run the function. So this is one that's going to take these data that we've just accessed from GBIF. So this tabular data here, and it's going to take the parameters that are set up in this table, species, latitude and longitude, the year and the month, and it's going to summarize it according to a specific sized grid. So these are the different parameters that you need to specify in the function, species grid summary. First is to input the actual data frame that you're using. The resolution is to change the size of the grids. So I've just set it to 1/4 degree. So that's about 28 kilometers. If your data has different columns, so as I said, this is straight from GBIF. So these things are all standard if you're using GBIF data. But if you're using your own local data, if you have a different name for the column that has latitude and a different name for the column that has longitude, year and species, etc., then you change that. Not in the function. So the function, we just click and that loads it into the system. But then in the next block where we actually run that code, this is where you would change it. So if nothing changes, you don't have to add in any of these because that's the default. But I put it in here so that you could see how you would change it. So if you do have something different, you can go in and change that. So I'm going to use degrees. So this 0.5 means quarter degrees. If you want to use meters, then there's a whole other process to go through, but it is an option there. So if we run this, all right, it should tell you there that raw observation data had 81,823 records. All right. And that the gridded data now has 858. So that makes sense. So we had individual points of localities where observations were made, and we've now summarized those into grids grid squares of quarter degrees, and there are now 858 of them. So the output that we have that's also built into the function is it's going to summarize it by species richness, so it counts the unique number of species, and it's also going to summarize by observations, so it just counts all the records that are in each of those grid cells. So we can summarize that further. The output has now swapped our degrees decimal, or whatever the name of your latitude and longitude columns were before. It swapped it out for a centroid latitude and longitude. So that is now the center of that grid square, so that we can use it as a point going forward. So we can aggregate those further if we want to work out the square root of the count, because it is quite large numbers. So you'll see later we can go and change it when we're symbolizing it. But that's just to illustrate that you can start doing, because it's now a data frame, you can go ahead and do all sorts of calculations on it. And that's just to illustrate. So now that we have it summarized into these smaller records, we can start looking at building plots. We want to first see, right, you run that. I'm not going to go through each line of code. It is annotated for you, but if you have a question, just pop it in the chat. So this, we're going to plot the new points that we've created, and we're going to change the size based on the count of the observations that we've made. So these steps take you through plotting the results. So at the end of the day, we've now got these squares, and the center points of those grid squares are now the new latitude and longitudes, called centroid latitude and longitude. And these colors represent the square root of the total observations. So you can see there's a lot more observations happening in Gauteng, as well as down here in the Fynbos in the Cape. So that's just illustrating for butterflies the number of observations that were made. All right. We can also go and summarize this further. So if we want to look at summarizing by these new grid IDs, so those are the individual grid sites, we can start looking at calculating sampling effort. So if we just want to count the total number of observations, as well as species richness, we can run through taking that grid counts, which was generated from the function we ran, grouping it by year and species to get the unique species richness, or we can go and do the sum of the counts that we've generated. So now you've got a new table that's going to look like this, where you've got the year, the species richness, and the observation count. With that in place, we can start making line plots, charts. In this case, if we run it, you see you have now the unique species and the total observations on different axes, because they are very different, the extent of those numbers. And we've plotted species richness in green and total observations in blue. You can start looking at maps. The first is just through the normal MATLAB plot. You run it, and it should generate a little static map. So these maps you can't zoom in and out of. This ePSG, those that aren't familiar with spatial data, this is the generic unprojected geographic code for the projection. So in most cases, you'll use this. If you're using meters, you'd need to know the specific meters ePSG code for the projection that you're using. So I'm not going to go into that now. This step could have been avoided because my stuff is already in geographic, but I put it in here specifically so that if you did have a different projection, you could go and run through this script on your own. All right, and once again, there's a lot of duplication, but it's just to help you out so that you can run through it on your own. And here's the plot. Now it's static. There's nothing I can do. I can't zoom in and out, and I can't change colors or anything like that. You can, however, turn this into an interactive plot. So the easiest way, without having any access to Google Earth Engine, is using a Floem map. So we loaded that package in the very beginning, so this should work. Once again, it's just setting the bounds so that we know exactly where this is going to plot. It's allowing you to export the results, because we are now turning this image that we see here, we're going to turn it into a raster data set. So that's basically like a matrix, but it's a format that's specific for spatial data. So it's going to go through this to rasterize that matrix that we had before, and it's allowing us to export this into our G drive. So if you have a different G drive, you can change this, but I've also added this section here. So if you don't have this specific folder structure, it will create it for you. So if you run these together, it should still work. But if you want to put it somewhere else, you can just change that output directory. Okay, so we run it. It has now created this, this species richness square root raster. So you could carry on without loading it into the system, but I want to illustrate how it will work to be able to load it in. So this is to plot. So this is the actual image overlay function that comes from Floem that we can start creating a plot. So we need to have this file created. If this previous step, if something went wrong and it didn't get created, so you don't have everything stored in this file structure anymore, then I've put in an option on on GitHub. So if you comment, or rather if you take this URL here, that's a link to the same file on our GitHub site, and replace it with the one that I have here, it should still work. But if you manage to go through the process of exporting, then it should work as it is. All right, so it's just defining the color ramps, making different colors, centering the latitude and longitude for the map, and adding it as adding a layer control to the map, or using the Floem package. So we haven't even got into Earth Engine yet. Right, so it's still thinking. Okay, so while it's thinking, once again, if this does not work for you, either change this directory, or the directory where this file is held, change it to the specific one you've made, or if the export didn't work for you, you can just replace it with this, because that I've uploaded into GitHub for you. All right, so it's done. Let's have a look. So you see, this one is now giving me the error that this notebook is not trusted, whereas I saved it as a copy, so it should have been. So let's just check here. If I do this, I have to do that again. I think somehow the saving of the changes changed. So let me just update that. Are any of you getting this similar error that it's not trusted? And if so, you need to save it to your local drive so that it is trusted. Okay, you run it again. All right, if yours worked correctly, you will have a new map jump up, which you'll see is connected to the network. So I think, which one did we use here? I think it's just using the standard street maps, the Google Street Maps. Oh, you see, I'm still getting this error, even though I did save a copy. Let me try it again to save a copy. And I need to double check that I am in the right. Yes, I am. It's fine. Okay, it says it's creating a copy, but it's taking a while. All right, while it's doing that, I'm just going to move on to the next section. So section 5 now is to create your first data cube. So these data have been brought in, and we've done some summaries and we've done some plots, but we haven't actually created a data cube yet. So remember, a data cube has got multiple dimensions. In this case, we've just got one dimension, or 3 dimensions actually, because we've got latitude and longitude, and then a value of some sort, whether it's species richness or species observations. But for it to be a true data cube, we need to have more than that, different dimensions. So what we can do is to make a simple version where we're aggregating the total observations per grid cell per year. So you need to think of what is the next dimension. So when we presented the introduction on the first day, we said a typical one would be the location, so latitude and longitude, and then year. And yeah, this is the grid ID, which we generated, the latitude and longitude, and the year. I've just kept the grid ID because that's quite useful if you need to link it later. And then running through that, we just preview a header of those outputs, and you'll see now you've got year, latitude, longitude, and then the actual years where they've given you the value. So now you've got a data cube, an observation count data cube for all the different years of the data that we had. Similarly, you can plot this. So this section here is just joining, because remember I said I wanted to keep this grid ID. See, now it's gone and copied it. So I needed that grid ID because I wanted to link it back to the observation counts that we did previously, so that at the end of the day, I can generate a raster from this and I can actually plot it. All right, I should just save. Okay, so just going to quickly run through these. I've saved this as a new version now. Don't know, let me run it together. All right, I don't know if that's going to go quick enough, so I'm just going to run through this as I have it. I did run it before, so the output should be there. All right, so this one is now turning essentially this cube into a raster cube. So that's a raster stack. So it's going to take the grid ID, link that to observations that were my observation count. That allows me to take the geometry data, so that's the latitude and longitude, from that and add it back into the data frame. And from that, we can then create a raster data set that we can plot. So running through those 2 code blocks, you should end up with this. This is exactly what a data cube is. Each one of these layers is a dimension in the cube. All right, you can then export these data out as a raster stack. All right, so if you run this, you can either change that directory or leave it as is, and this will then create a raster data set, but we also want to be able to mask it. So in this case here, you see it's got everything outside the boundary of South Africa isn't there. So this is a similar thing, but with sampling effort now saved as a raster. You can do the same thing with the species richness. So these blocks are exactly the same, except I've changed it now to species instead of count, which were the observations. I've gone through and I've joined the table to the grid polygons. So those are what were created when we ran that function that created the grids and summarized the points within it. All right, we rasterize the species richness, and then we create a non-interactive map just to double check that everything is working. And then we can go and save it as a raster data set here, right? And it tells us here that it's got 26 annual bands. So that's what makes it a cube. So it's got 26 dimensions. Now, this is the part for Earth Engine. So we're running out of time, but I do want to just go through being able to access data from here. And if you go through this on your own time, the important thing here is Earth Engine, the data catalog. So if you click on that, these are all the different data sets that we have. If you click on all data sets, it will list all of them, and you'll see there's a lot to choose from. And either one of these, if you click on it, okay, it's taking a little while, but I want to show you the part that's important for importing data, whether it's through Colab or whether it's through Earth Engine itself. Keep in mind that if you're using Earth Engine, you will be programming in JavaScript, whereas everything we've done now in Colab has been with Python. All right, so this Earth Engine snippet over here, this EE, this is the part that you need to know to be able to import this data set. So EE image means that it is a single image. It only has one band, but this is the info that you need. If we go back to our thingy, this is the info that we'll need to plug in to our notebook when we start to bring things in. Before we do anything, it's good practice just to set up the inputs that you want. So if you want to be working in a specific time period, then set these up as objects rather than having to change them for every single time you import something. So you set from the beginning, this is my start date and my end date. From that, you can create a month list and a month IDs. But the most important is this, you need to have your start date. So if you run that, all right, here we can bring in a boundary. So remember, we use the boundary in a different way through GitHub. In this case, it's a feature collection, which is a spatial object already that's saved in my Earth Engine project. So I've created an open file there. So this should run for you. If not, then you can use the previous version from GitHub, and that will also work. But this is an asset that should work. All right. Then this creates the first map. So you need to be able to set up your map using this GE map. Now this M, this is your map. So whenever you add anything to the map, you need to bring in that M. If you call that something else like map or my map, then that will be the one that gets added in for each of the whether you change the base map or whether you change the layers, you need to use that. So this is the first basic map. I've set the size of it. These are the typical base maps that you can use. So I added those in, and you can grade them out or comment them out. And I've just added the South Africa boundary, which is what I had before, all right? And it will add on with that. So it should look like this. Okay, you shouldn't have all these blues. All right, there's always a problem when you're running things live, but you should end up with a view like this, but only with the boundaries of South Africa on it. There's a lot of different layers on here because of the different run that I made, but we don't have time to rerun through a new version, which I copied to my hard drive, to my G drive. So I've put the options here where you can bring in elevation. You can bring in, and then you can export that elevation. So if you want to take it to your G drive or to a local drive, you can export it. Human population data. All right, road networks. And then it takes you through a whole process to generate distances from roads and things. So you'll see there's a lot of different parameters here that you can add in. We are running out, well, we've run out of time, and there's a lot more to get through. So you can go through that on your own. As I said, I set up the tutorial so that it's hopefully easy to follow, and it's annotated throughout the script so that you can read exactly what's happening in each step as you go through it. So work through it on your own time. Maarten, I think, has circulated in the chat box a link to a Google Doc where if you have any specific issues that you'd like to address, we'll try and incorporate it into next week's session. But we also want to be a bit flexible. So what we could do is we could run through some more of the theoretical side of how you disseminate your data on things like Zenodo or GitHub and things like that. And then rather run through the script again in totality or touch on things that Maarten covered last week that everyone got stuck at. It's up to you. So we'd like to hear from you so that we can tailor next week's session to be the most useful as possible. So please fill that in, and then we will decide what to do next week, whether we cut the Zenodo and GitHub sessions a little bit shorter and refocus on running through some more modeling, or if you want to focus more on Earth Engine, this is your chance to try and help us customize the last lesson next week for you. So yeah, I'm sorry we ran out of time, but please do go through it. And if there's any questions, I can answer them. All right, so I think Maarten has been answering the questions as we go along.
Yeah, I don't see any pressing questions now in the chat, but I repeated already 3 times, but I will say it another time. Please add it to the Google Doc, and then we can have a look at it.
Yes. Yes. So we'd really like to address things that are useful to you, especially the way that the Zoom call is set up. It's not easy to interact with everyone that's attending. So this is the best way we could think of to try and cover your needs in the last session, because that will be our last time to cover a few things. And then I think Maarten also put in their ideas for the next mini school. If you want to see something different, we'll present this version of the data cubes with Earth Engine every year, but we're looking for ideas for the last session looking for ideas for a new mini school that we'd like to present. So please, we'd love your input. All right, so I don't see any raised hands or any other specific questions in the chat, but I think that Google Doc is there for you to have more time to think about what you want to ask. So the link will be there until next week. So we will keep checking that. So if you didn't get a chance to ask your question now and you want to think about your question a little bit more, you're welcome to just plug it in there. We'll keep checking that Google Doc.
Okay, if we don't have any further questions, I would like to thank Sandra and Maarten. Thank you very much. Yeah, thank you very much. Much appreciated. Thank you for this. And if I'm correct, then next week our last session. Okay,
Right.
thank you very much for all the trouble preparing this. We really appreciate. Thank you so much. And if anybody has any questions, you know how to get hold of us. Thank you so much. And yeah, I can see everybody applauding and saying thank you very much. Thank you. Take care. All the
Right.
best. Okay, we stay in touch. Thank you.
Thanks, Renee. Thanks, everyone, for attending.
Thanks, everyone.
And we'll keep an eye open on the Google Doc. And we'll see you next week.
See you next week. Thank you. Goodbye.